Okay, here we're going to do a two-tailed test for the proportion because we're not talking about the mean, we're talking about the proportion, and these are the hypotheses that we came up with earlier. Let's go like that. And what we're going to use for this is we're going to use the difference of the two proportions from our sample. From our sample, 809 out of the 1023 adults were carrying smartphones, and 254 out of the 348 teens were carrying smartphones. So this is our this is our sample statistic. This is what came from the sample. It's p hat from our adults minus p hat from our teenagers. So that's what we got to start with. Now, the z-score is going to be this minus the null hypothesis. So that would be z. Under the null hypothesis, we're saying that that difference is 0, divided by the standard deviation. And remember how crazy that standard deviation was. It was pq over n1 plus pq over n2, all inside that square root. So it's going to take a second to figure out what those things are. So let's quickly figure out those things. The pooled p is going to be this plus this divided by this plus this. Does that make sense? That's the p for the entire sample. Assuming that the samples are the same, that they come from the same population, we can just pool these two together. So 809 plus 254 all over 1023 plus 348. That's going to be our p bar, or whatever we want to call that. That's the pooled estimate. So let me pull out the old calculator and get that p bar. So turn this guy on, clear that guy off. 809 plus 254 divided by 1023 plus 348. So we get a pooled estimate for the proportion of 77.5%. So we are assuming that about 77.5% under this null hypothesis, if we think about these as coming from one sample, 77.5% of the total people in that whole sample were carrying smartphones. Alright, so let's see what our statistic is on top. This is going to work out to be, let's just calculate it one step at a time. I'll clear that out. 809 divided by 1023. That's 79%. 254 minus 348. That is, oopsie. Let's try that again, Hauss. 254 divided by 348. That's 72.9. So let's keep it to three significant digits. 79.1 minus 73.0, because 73.0%. Because if we round this to three significant, sorry, you can't see that. If we round this to three significant digits, it's 79.3. Notice 254 divided by 348, 809 divided by 1023. That's how we get those two numbers. Okay, so that's what our result says, and that is a difference of 0.061. So it seemed like the adults were carrying smartphones, a little bit more often than the teenagers. Let's see if it was significantly more often, if there was enough difference for it to be significant. So to find our z-score, we will take this total, this total, this total, subtract 0, and put it over our standard deviation. So 0.061 divided by the square root of 0.775, and that's multiplied by the q bar, and if the p bar is 0.775, the q bar is going to have to be 0.825. no, 0.225, my bad. Because this plus this has to add up to 100%. We're going to take that and we're going to divide it by the adults, the total number of adults, which was 1023. And then we're going to take that 0.775 times 0.225 and divide it by the total number of teenagers. The total number of teenagers was 348. So that's going to be our z-score, the difference between our sample divided by the square root. Divided by the standard deviation. So let's put it in here, see how it comes out. 0.061 divided by, and I'm going to start this big old square root, 0.775 times 0.225, all divided by 1023, plus 0.775 times 0.225 over 348. Close that thing, press enter, and we get a z-score of 2.35. I can't really see what that last thing is. My calculator's a little bit messed up, but I'm going to go with 2.35. So our z-score worked out to be 2.35. We were looking at a two-tailed test, so what we want to know is the area in these two tails combined greater than alpha? I forgot to tell you what alpha is, but let's just say alpha is 5%. So let's see if the area in that thing is greater than 5%. This area is the p-value, and if the p-value is less than the level of significance, we're going to reject the null hypothesis. So get the calculator over here. I'm going to hit distributions. I'll look at a normal CDF. I'm going to go from 2.35 to infinity, and I'll multiply the result by 2. 2.35, comma, infinity, comma, mean of 0, comma, standard deviation of 1. Take that. I'm going to double that because I'm looking at both tails. So our p-value is approximately 2%, 0.018% or 0.019% actually. So p-value equals 0.019. So consequently that's below alpha, and this is enough evidence to reject the null hypothesis. We can reject the null hypothesis. So yes, there is evidence that teenagers and adults carry different proportions of cell phones.